Hi, welcome everybody. This is my session, Building a Kubernetes Operator in Quarkus. My name is Fabian Lange. I'm VP of Engineering and co-founder of Instana. So before I start, I want to quickly explain all those three terms I used in the title slide. So I hope you all are familiar with Kubernetes, which is a container orchestration system. So it makes containers run, it makes your applications run in a way that you desire. But what is then an operator? Well, there are certain manual steps that you still do when you run application in Kubernetes. So when you have deployed your YAML files, so you might need to do some adjustments. And an operator is designed to do exactly that. It is designed to do runtime changes that usually humans would do. And we are going to do this in Quarkus. Quarkus is a Java framework, very much similar to Spring Boot, for example. Why it's especially designed for Kubernetes is because it is low footprint. It's fast startup time. It's optimized to be run in Kubernetes, and it can run in a Java mode and in a native mode. So quickly give you a little bit more of a detailed example on what an operator would do. Imagine you have an application that uses a database of sorts, and you want to tell the application where the database is. There are several options to do so. One option would be, as soon as you start up the database, you make an entry in something like console or etcd, where you put in the IP address of that pod of that database, and when your application then starts up, it can read that entry from the database. But that's not really ideal, because this is like a manual step, and it requires you to look up something. This is something an operator can do. An operator can go ahead and look into the running database pods and then figure out the IP addresses that are reachable and let the application know. And we are going to do that in a live demo now. So why am I here? Because I've done that before. Instana is an APM tool, so application performance monitoring tool. And most of our customers run in Kubernetes. So they have tons of applications in Kubernetes that they want to understand the performance of. And we have an agent that runs also in Kubernetes, and it takes care of all those. But our agent also needs a little bit configuration, and we want to be zero configuration. We want to make it fully automatic. So we wrote an operator for it. It's open source. You can look it up on GitHub and see how we have done this to configure our agent. So let's wake up my laptop that has fallen asleep. I hope you haven't. Go over here. And now we're going to build it. So how do we get started with Quarkus? Well, it's pretty easy. There is something available from Quarkus themselves, a Maven archetype that we can use. Let's do the... So this is the Maven archetype we are going to use. It's the Maven Quarkus plugin, and we are generating an example project. It comes with a REST resource by default. We call it hello resource. So let's run this, and it will create an Eclipse project in this case. All right. And now I can open this project, import it into Eclipse, so that we can have a look what has been generated for us. So there are several things generated for us. This hello resource I just pointed out, it's very easy. It says hello when you ask it on /hello. This is actually quite useful to have web resources in every pod for Kubernetes health checks. Kubernetes wants to know, is your pod still alive? Is it still working? And you can configure a health check for doing so. So have a web resource like this one that can answer, OK, I'm still working fine. What also has been generated is a Docker file. And there are two Docker files, one for JVM mode and one for native mode. In this demo, I'm using the JVM mode because the native compile takes like 5 minutes, and I don't have 5 minutes. So we need to be quick. This is the Docker file that we will use to to build and deploy our operator, but I need to add something to it. We want to talk to the Kubernetes API. And the Kubernetes API speaks HTTPS. It wants to have a TLS connection, and the Docker file is designed for very minimal Alpine Linux that doesn't have any TLS support. So we need to add it to that. Let's do it like here. Run apk add NSS. So NSS is a library that supports TLS connections on Alpine Linux. And APK is the program we use on Alpine Linux to add libraries. Okay. Now that we have done that, we need a client library to talk to the Kubernetes API, because we don't really want to write this all on our own. We want to recycle something that's existing. And there is a client called the Fabric 8 client. And there is a Quarkus version of it that has been optimized to deal with the reflection that is in this client so that it works with the native compile mode. So let's do that and do add extension. So this Maven archetype has add extension, and we are adding the Quarkus Kubernetes client, and I'm also copying a class I prepared so that I don't need to do that much typing here, but I'll walk you through that in a second. All right, this has been created. So let's first look in the POM XML. This is a Maven project, so it has a POM XML. And there we have now an additional dependency, the Quarkus Kubernetes client. Of course, you can also add it manually in your POM XML, but I like that they have a utility for that. So next, look at the class we just copied. This uses dependency injection. The dependency injection that comes by default with Quarkus is weld CDI. And we are, first of all, trying to find out what namespace we are running in. Luckily, Kubernetes is generating for us a file at this location that will tell us which namespace we are running in. So this demo will use the default namespace, but this can be quite handy if you're using several namespaces and want to restrict your ports to certain namespaces. And then we're making this to produce a string named namespace that we then can recycle over here and generate the default Kubernetes client in this namespace. Now let's go ahead and actually use this. So let's build a class called port listener. So what do we want to do? Well, we want to do something when this application starts up. So let's implement a startup method. And how to make it a startup method? There is events in this Quarkus event system, and one event is the startup event. So we can execute it when it happens, when we observe it. But I need to spell it correctly, otherwise it won't work. So this is the startup event. It comes from, actually this one comes from JavaX Enterprise, and the startup event is from Quarkus. Okay, what do we want to do on startup? We want to query the Kubernetes API for all the running pods. So first of all, we need to inject a Kubernetes client that we just created. Here we go. And we need to inject it. All right, so now we have a Kubernetes client that we can use. And it has tons of things that we can do with it. But I want to list all the existing pods that we have. And actually, I want to have a Java list from that, so I call get items pods. So what do we do with this list of pods? Let's say we print it. And the really interesting information is in this metadata. Get name over here. So now we would just print the name, but there is something else that we need, and I'm going to spoil this for you already. So Kubernetes has a concept of versioning. So whenever changes to your pods, your configuration files happen, it will attach a new resource version to it. So let's print this as well, so that we can understand in what resource version this pod is. All right. So now we observe the startup and list all the pods that are existing at startup. But we also want to do more. When there are changes happening at runtime, we want to get to know that changes are happening. So what we can do for that is we can listen to changes by watching them. So we need a new watcher, and that uses generics. The Fabric 8 client uses a lot of generics. So it's a watcher of type pod, and that has two methods. One is onEventReceived, which receives the action that was observed and the pod, and the other is onClose. So let's deal with onClose first. OnClose is being called when this is terminated gracefully or exceptionally. Let's handle the exception case. What do we typically do when we get an exception? Yes, correct. System exit. And of course, print stack trace. So why is this actually not a bad idea to do? In Kubernetes, your pods will get restarted when they crash. And when there is a problem, maybe there was a network exception talking to the Kubernetes master, we want to retry it. And by exiting our process, Kubernetes will see that our application crashed, the health check is no longer responding, and it will restart the pod and potentially clear the network issue that was happening. So it might work afterwards. So now what do we do when we receive an event? This out. I want to print this again. Let's actually take this over here and rename this to pod and this to action. And then let's say receive action on pod. All right. So now we will print whenever actions happen. On pods, we will print similar lines. Now you might ask yourself, well, what happens actually here in line 26 when before we start watching, a pod is started? We will miss it. The answer to that is no. So while this gives you the current state of pods, watch will return a buffered version of all the events that have happened in the last time. So watch will actually give you the things that happened before again. And for that, you really need to have the resource version so that you know that you have seen the event. So you can put it, for example, into a map and then see, okay, I've handled this event, I have seen this pod in this resource version already. All right, this is it. So let's deploy it. And do like this. So I'm going to do Maven clean install, and then I'm using kind to load this into my Kubernetes cluster. I'm using kind as a local development environment for Kubernetes. So you might be familiar with Minikube. Kind works approximately the same way. And this is now then packaging the app. It's running a Maven compile. It's putting it into the Docker container. It, as you see in step 4, it added NSS as I added to the Docker file. And now it tagged this and loaded it in the container and loaded it into the cluster so that we can run it. Before we run it, however, I want to have a demo pod up that we can actually observe running and restarting and changing configuration. So let's deploy a simple one. The one I use is Nginx. Let's deploy an Nginx container. So the port nginx1 has been created. So we can do kubectl, get ports, for example. And we see nginx is currently being created. And next, we want to deploy our operator image. And this needs a little bit more. So besides the operator, I'm also deploying role-based access control, because we want to access the Kubernetes master, and by default, you are not allowed to. So we are deploying role-based access control as well, so that we are actually allowed. And now maybe deploy another nginx container. All right. So now that all those containers are running, let's have a look at the output of of our operator. So this is the output of our operator. First, it found the port nginx1 in version 1862, and then it found itself, because itself also was running when the startup event was received. And then we received the action. And here you can see what I mentioned with the resource buffering. So we're receiving an added event, which is the resource version 1862, which is the same here. So we should know that we handled it already. And the same for ourselves. And then when nginx2 was started, we see an added event, and we see several modified events. That's when container is starting up. It goes through several phases, and each of that is a modification. So this was a very quick introduction in how you can write a Kubernetes operator. So what can we do now next with it? So next, we could do a custom configuration file. We can deploy custom YAMLs, similar to how we deploy pods. And we can put configuration into those YAML files. And then read it the same way as we have read the pods. We can read that configuration file. Or we iterate all the running pods to figure out which one is our database pod, get its IP address from its metadata, and then tell some other pod, for example, our application pod, that this is now an additional IP address for a database. I hope this was interesting to you, and I encourage you to try it yourself. Try Kubernetes if you haven't, and maybe if you have tried Kubernetes and you're a little bit lost in all the things that are going on, I encourage you to come to our booth. It's right over there, the second aisle, and we have a great monitoring solution which gives you more insights on what's running, how's the performance of things, how's availability, how are you doing on resource consumption, what's the source of errors, how many users are affected, and more alike. Thank you very much for your attention.